In this problem, we would be talking about the distance of a point from a line. As you can see on the right side, if you are given a point and a line and you are asked to compute for the distance of this point from the given line, then the first thing you need to do is to draw a line that would pass the given point and would intersect the given line perpendicularly. And this distance d is the distance that we are after for. And in school, we are taught that there is an existing derived formula on how to compute for this distance, and it is given by this equation. But if it's your first time to encounter a problem involving this topic and you don't know this formula, how would you manage to answer that one? Me, personally, when I first encounter a problem involving this topic, I don't even know that there is an existing derived formula that would compute for the distance of a point from a line. But I able to answer that one with my knowledge in trigonometry and geometry. To illustrate what I did to that problem, let's try a problem. Let's find the distance between point A having a coordinate of 3, 9 and line y is equal to 2x plus 5. To solve this kinds of problem, let us first graph point A and the given line. Let's consider this standard Cartesian plane. So let's first graph the given line. And in order to roughly and simply sketch a line, we need at least 2 points along that line. The two easiest points of the line that we can get are its intercepts. So let's first consider the x-intercept of the line. When we say x-intercept, it is a point along the line wherein the y-coordinate of that point is equal to 0. And given that condition, we can compute for the associated x-coordinate of the x-intercept. So, the given line is y is equal to 2x plus 5 such that y is equal to 0. Again, we are using the condition y is equal to 0 because we are looking for the x-intercept, and x-intercept is the point along the line wherein the y-coordinate of that point is equal to 0. So y, which is equal to 0, equals 2x plus 5, and we get the x-coordinate of the x-intercept of the line to be negative 5 halves. And if we are going to plot the x-intercept, it would lie on the x-axis. Now, let's consider naman the y-intercept of the line. When we say a y-intercept, it is the complete opposite of x-intercept. It is a point along the line wherein the x-coordinate of that point is equal to 0. Again, given that condition, we can able to determine the y-coordinate of the y-intercept. So, the given line is y is equal to 2x plus 5 such that x is equal to 0. We are using the condition x is equal to 0 because we are looking for the y-intercept of the line. Y-intercept is a point along the line wherein the x-coordinate of that point is equal to 0. So, y is equal to 2x na kung saan the value of x is equal to 0 plus 5, and we get the y-coordinate of the y-intercept to be 5. And if you are going to plot the y-intercept, and this point would lie on the y-axis. Now that we've plotted 2 points of the given line, we can now simply graph the equation of the line. Let's say this is the given line, y is equal to 2x plus 5. Now, our problem is to plot the given point A because there are numerous possible locations where the given point can be plotted. We can say that point A might be located above the line or below the line. we can also say that point A might be located on the right side or left side of the given line. So in our solution for this problem, we will first assume an initial position or location of the given point A. And in our solution, I assume here that point A is located below the given line, or I can also say that I assumed point A is on the right side of the given line. So let's say this is point A having an x coordinate of 3 and y coordinate of 9. To verify our assumption on the location of the given point, let us first recall the concept of domain and range of a function. So, on our next step, we will be determining the domain and range of the given line. When we say of domain, it is the set of all possible values of x, wherein if we try to substitute those values on the equation of the line, we will yield a real value of y. And by principle, the domain of a function of a line is all the values between negative infinity plus positive infinity. If you try to get a value within this domain, you will yield a real number or real value of y. And when we say noman of range, it is the range of the values of y when we try to substitute all the values of x. And by principle, the range of a function of a line is between negative infinity plus positive infinity. If you try to get a large positive number from the domain and try to substitute on the function of the line, you will yield a large positive value of y. So why did we define the domain and range of the given line? It has something to do on our next step. Our next step here is to project a vertical line that would pass the given point and would intersect the given line. And how sure we are that if we project a vertical line that would pass point A, then it would intersect the given line? It is by the value of domain. Because if we are going to choose any values of x between negative infinity plus positive infinity, then there will always be a point on the line na kung saan yung x coordinate niya is between negative infinity plus positive infinity. And that's the proof that if we project a vertical line that would pass point A, then it would indeed intersect the given line. And let's say that intersection as B. If you would to inspect points A and B, these points lie on a vertical line. Meaning, if 2 points lie on a vertical line, their x coordinates are equal. So let's try to solve for the y coordinate of point B. So given the function of the line, y is equal to 2x plus 5 such that x is equal to 3, which is the x coordinate of B. So we will get the y coordinate of B as equal to 11. Our next step naman here is to project a horizontal line that would pass point A and would intersect the given line. Again, how sure we are that if we pass a horizontal line that would pass point A would intersect the given line? It is on the value of the range of the function of the line. Lahat daw ng values ng y between negative infinity plus positive infinity, there will be a point on the line na kung saan yung value ng y na yon is between negative infinity plus positive infinity. And that's the proof that if we would to project a horizontal line that would pass point A, it would indeed intersect the given line. So let's say the intersection as C. And if we would to inspect points A and C, these points lie on a horizontal line. And what we can say about 2 points that lie on a horizontal line? If 2 points lie on a horizontal line, their y coordinate is equal. Now, let's try to compute for the x coordinate of C. So, given the line of the function as y is equal to 2x plus 5, such that the y coordinate of C is equal to 9. So basically, we will get the x coordinate of C as 2. Now that we've computed the coordinates of the intersections of those lines that we've projected vertically and horizontally that passed the given point A, we can now verify our assumption on the location of point A. How? By comparing the coordinates of the intersection and the given line A. First, let's compare A and C. Sabi natin kanina that A and C lie on a horizontal line, meaning that their y-coordinate is C. So if we try to compare the x-coordinate, point A has an x-coordinate of 3 while C has an x-coordinate of 2. This only means that our assumption that A is on the right side of the line is correct. Another proof, compare point B and A. Sabi natin kanina that points B and A lie on a vertical line, meaning their x-coordinates are equal. So if we try to compare their y-coordinate, B has a y-coordinate of 11 while the y-coordinate of A is 9 lang, meaning it is justifiable that B is above point A, meaning yung assumption natin kanina sa location ng point A is tama. So, where's the distance that we are looking for? Is it the distance between C and A or A and B? Neither of the two. The distance that we are looking for is first, we need to draw a line from point A to the line, and this line should be perpendicular to the given line y is equal to 2x plus 5. Let's consider this intersection as D, and the distance of this line is D, and this is the distance that we are after for. So, let's first denote the distance between points C and A as x, and denote the distance between points B and A as y. So let's compute for the values of these variables. So let's first compute the value of y. Y is the distance between points B and A. And if we are solving for the distance of 2 points, we basically use the distance formula. But in our case, points B and A lie on a vertical line and their x-coordinates are equal. And to simply compute the distance between 2 points that lie on a vertical line, we need only the difference between their y-coordinates. So y would be equal to 11 minus 9, which is equal to 2. So let's now try to solve for the value of x. X is the value of the distance between C and A. Again, if we compute for the distance of 2 points, we basically use the distance formula. But in our case, since C and A are points along a horizontal line, their y-coordinate is equal. So to basically compute for the distance between 2 points that lie on a horizontal line, we simply compute for the difference of their x-coordinate. So x is equal to 3 minus 2, so we can get x is equal to 1. If you try to look on our graph now, we've derived polygons, right triangle in particular. Look at this one, CAB. CA is a horizontal line. BA is a vertical line, meaning lines CA and AB are perpendicular. Therefore, the triangle formed by CAB is a right triangle. Look at this one also. CAD. DA is the distance between point A and D, and it is the distance of the given point to the line, meaning this line is perpendicular to this given line, meaning the triangle formed CAD is a right triangle. Likewise, the triangle formed by BDA is a right triangle also. These triangles are important in solving for this D that we are looking for. So let's try to isolate triangle CDA. Again, sabi natin kanina that length DA is the distance of point A from the given line, meaning this line and this portion of the given line is perpendicular to each other. And we denote that the distance between D and A is D, which is the distance that we are looking for. And the distance between C and A is the variable x na denote natin kanina, and we solve for its value, which is equal to 1. Now, to compute for the missing properties of a right triangle, we need at least two known values of the right triangle aside from this 90-degree corner. So, ano pa yung values ng right triangle na ito that we can get from the problem? Basically, ang makukuha natin is the value of this angle that we've denoted here as theta. If we would to reflect this angle from this graph, ay ito yun. Now, again, try to inspect triangle CAB. Line BA and CA are perpendicular to each other. Thus, the triangle formed by points CAB is also a right triangle. So, let's try to isolate also that one. So, this is A, this is B, this is C, and the distance between A and C is x, which is equal to 1, and the distance between A and B is y, which is equal to 2, and this is the angle theta. So, our main target here is to compute for the value of theta from this triangle, and yung makukuha nating value is gagamitin natin sa triangle na to compute for the value of t na hinahanap natin. So, from triangle BAC, the tangent function is the one that would relate this side and this side relative to this angle. So, tan theta is equal to opposite, which is y, over adjacent, which is x. So, substituting the value, we would get tangent theta is equal to 2. In this video, I presented two methods on how to compute for this distance D that we are looking for. So let's proceed with method 1. So from this equation na nabuo natin kanina, tan theta is equal to 2, we can now get the value of theta, which is equal to 63.435 degrees. Using this angle to this triangle, we can now compute for the value of D. By inspecting this triangle, the trigonometric function that would relate the side D and side X is equal to 1 relative to the theta angle is the sine function. So, from triangle ADC, sine theta, which is equal to 63.435 degrees, is equal to the opposite side, which is equal to D, over the opposite side, which is equal to 1. From this equation, we can now basically compute for the value of D, which is equal to 0.894 units. Let's proceed to the last method, or method 2. Ang pinagkaiba ng method na to compared to the first method, ang ginawa kasi natin on method 1 is we compute directly the value of theta, which is equal to 63.435. Ang gagawin natin dito to look for the value of the trigonometric function mismo and not the angle itself. So, let's proceed for method 2. So, from triangle ADC, sine theta is equal opposite, which is equal to D, over the hypotenuse, which is x equal to 1. Sabi natin kanina, on our method 2, we would not directly compute for the value of theta, but we would basically compute the value mismo ng sine theta from this triangle. So let's first compute the hypotenuse of triangle BAC using the Pythagorean theorem. So we will get the hypotenuse as the square root of 5. From this triangle, the value of sine theta is opposite, which is 2, over the hypotenuse, which is equal to square root of 5. This value is the value of the trigonometric function sine theta, and we only need to equate that one with D over 1, and now we basically get 2 over the square root of 5 And if you would do input that in your calculator, you would approximately get 0.894 unit, which is equal to the value of t that we've get on method 1. So to verify whether our answer is right or wrong, let's check it by using the derived formula given by this equation. So first thing we need to do is to transform the equation of the line into its general form. And that can be done by simply transferring this term on the other side, and we will get 2x minus y plus 5. The a variable on the formula pertains to the coefficient of the term on the equation of the line having the variable x. B is the coefficient pertaining to the term having the y variable, and c as the constant. This x here pertains to the x coordinate of the given point, while y is the y coordinate of the given point. So a here is 2, b here is -1, c is equal to 5. Again, x is equal to the x coordinate of the given point, which is 3, and y here is equal to the y coordinate of the given point A, which is equal to 9. If we try to substitute all these values on the given formula, we will yield a value which is equal also to the value that we've get without using this formula. I hope that you've learned a lot. Thank you, and see you sa next videos.